paper named in your syllabus as Earth and Climate. So basically it is climatology, that is the study of climate. In your undergrad syllabus, the paper is named as Earth and Climate. Now, if we look at the word climate, and from that the uh, climatology word comes. So basically, climatology or the word climate came from two Greek words. The first one is klima, which means the slope of the earth, that is the latitude-wise variation of earth, and the second part, that is logos, which means the logical approach or scientific study. So if we club these two words, klima and logos, it makes the word climatology, which basically try to uh, elaborate the uh, part of the scientific study in which we deal with the varieties of climatic conditions found around the earth and the process and its effect over the earth's surface, as well as their distribution over the earth's surface. Now, in our daily life, we use the terms weather and climate almost synchronously, but there is a huge difference between the meaning of these two terms. Weather actually refers to the condition of the atmosphere of any given point for any given time. So it is the short-term prediction of the atmospheric condition. Now, what do you mean by atmospheric condition? Atmospheric condition means its temperature, pressure, moisture content, that is humidity, cloudiness, precipitation, visibility. So all these atmospheric conditions are said for a given place for any short period of time. Then that means we are describing the weather condition of that place. In contrast, when we use the term climate, that depicts the weather condition or atmospheric condition of an area, but in this case the time span is huge. So when we going to depict the climatic condition of an area, we are dealing with much larger time span. Say for example, we are saying weather in terms of days, in terms of weeks, in terms of months, in terms of seasons. It is the rainy season, dry season, wet season. Tomorrow there will be some precipitation in the amount of rain in the form of rainfall, such and such. So these are the weather conditions which we are describing for any particular place. But when we are going to say the climatic condition of that place, we have to deal at least for a decade time span or even more high, hundreds of years or thousands of years. So that is why it is said that climatic condition is a large time phenomena, and in simple way, climate is basically said that is it is the average weather condition of any place. Say for example, in your hometown, throughout the entire year, you will evidence hot summer, then the rainy monsoon times, then autumn, then winter, and the year ends with spring. So throughout the entire year, you will evidence every weather conditions. You will evidence extreme hot, about 40 to 45 degrees centigrade, as well as you will also evidence the cold condition, 5 degrees centigrade, 10 degrees centigrade during winter times. So these are the weather condition of your hometown for any particular time. Now, if someone asked you to say about the climatic condition of your hometown, then you have to average these weather conditions for that particular place, that is for your hometown. And you have to say that your hometown have a climatic condition of around 25 to 30 degrees centigrade. It has a rainfall of at centimeter per year, like this. So you have to average the entire atmospheric conditions throughout the year, and then only you have to after that you have to average those weather conditions for a longer period of time, at least tens or hundreds of years. You have to observe those data, and then only you can say the climatic condition of your hometown. Now, whenever we are going to study the climate of an area or the entire earth, the earth, as we know, is composed or of four spheres. The first one is the solid lithosphere, second is the liquid hydrosphere, third is the gaseous atmosphere, and the fourth part, that is the living beings of earth, which is known as the biosphere. Now, together, these four spheres interact among themselves, and they will govern the climatic condition of any region for a longer period of time. So together with the interaction of these things among themselves, the weather conditions will change for any particular place, and with time, for a longer period of time, that changing weather condition is resulting the change in climatic condition of that area. So these four spheres are very important for governing any change in the climatic condition of an area. Now, if we look at the Earth's climate system and interaction of its component, the main causes which force the change in Earth's climatic condition, that can be grouped in two parts. One is the external causes, that is the external forcing. What are the external causes? Main causes are the change in plate tectonics, change in Earth's orbital motion, and change in intensity of sunlight. So these three external causes force to change the climatic condition of the earth. Along with these external causes, the internal energy of the earth also have some influence on the climatic condition. Now, the causes which are responsible or which force the earth's climatic condition to interact the different components of the earth differently. The components are atmosphere, that is the gaseous envelope around the earth, vegetation, or more precisely, more widely, you can say it is the biosphere, that is all the biological or living entities, the ice cover, that is the cryosphere, the liquid water, that is the ocean, and the topography or geomorphology of the area, that is the land surface. So all these five components of the earth, their interaction, type of interaction or rate of interaction, that will change or that will happen differently depending on the severity of the external and internal causes, and depending on the different interactions between the earth components, changes happened, that is the results, and these changes are found to occur in atmosphere, found to occur in the ice cover over the earth's surface, that is the cryosphere, changes in biological forms, changes in ocean, that means the ocean's composition, liquid water, chemical composition, um, percentage of dissolved salt, ocean a cover extent, and lastly changes in land surface due to the interactions of different components with the earth. The topography or geomorphology of earth also change with time. So we came to know that one major uh, thing which is going to change due to the interaction of different earth components is the atmosphere. And the atmosphere of earth means that it is the gaseous envelope which surrounds the earth. Now there is a there are two terms, atmosphere and air. We use these two terms very frequently and often synchronously also. Now, atmosphere is the gaseous envelope that surrounds a planet or any celestial body. In contrast, the invisible, odorless mixture of gases surrounding the special planet Earth, that is known as air. So basically, air is the atmosphere of Earth. For any celestial body of the universe, the gaseous envelope is known as atmosphere. And as we told previously, or as we know that Earth is special, so the atmosphere of Earth is named by a special name, and that is air. Now, if we try to find the origin of the atmosphere, uh, we already know that Earth appeared about 4.6 or 4.7 billion years ago, and at the beginning of the Earth, there was many hot gases. Basically, Earth was a uh, globular gaseous mass which have a temperature of around 8,000 degrees centigrade or even more. And through time, from these gaseous mass, they will uh, gradually cool down and form the present day solid Earth with its internal portion is still in liquid condition. Now, initially, when the Earth formed, that means the during the first time when uh, due to the cooling of the external part of the earth, the start of formation of the solid crust is going uh, to occur. At that time, the gases exist around the earth are mostly the toxic hot hydrogen vapor, that is the steam, carbon dioxide, carbon monoxide, nitrogen, ammonia, methane. So all are toxic gases. Now, with time, we also know that there are many times in the earth when the atmosphere removed from the earth, there is no atmospheric cover, and again, due to some internal processes, mainly the volcanic eruption, the internal portion of the earth gradually cools down, and the dissolved gases within the molten material, within the lava, they try to move towards the lower pressure zone, towards the earth's surface, and gradually, with time, again the atmosphere, again the gaseous envelope settles or establishes around the earth. Now, if we look at the composition of the primordial earth, that is the gaseous composition of the atmosphere of the primordial earth, all the gases are toxic and there was no free oxygen. And if you look at the present day atmospheric composition, in present day, we found that there was about 21% oxygen and 78% nitrogen, with some other accessory or minute amount of other gases such as carbon dioxide, argon, neon, oxygen, oxides of nitrogen, methane, krypton, carbon monoxide, etc., etc. So you can see that there is a huge change in the gaseous composition of the atmosphere. One major change is the oxygen deficit, or rather you can say oxygen absent atmosphere to the present day oxygen rich atmosphere. So the question comes that if the early atmosphere of the earth is completely devoid of oxygen, so from that initial atmospheric cover, where from the present day oxygen come? Now there are two schools uh, which elaborates the appearance of oxygen in the Earth's atmosphere. The first school believes that oxygen produced or oxygen appeared in the Earth atmosphere due to the falling of ultraviolet ray on the water vapor floating in the atmosphere. So when ultraviolet ray fall on the water vapor, the H2O molecule is divided into two parts. One is hydrogen, another is oxygen. Now, as hydrogen is very uh, low in weight, so it goes out from the Earth atmosphere. It escapes the gravitational force of Earth, and as oxygen is relatively heavy, it stays on the Earth's atmosphere, and with time it makes the O2 or oxygen molecule or oxygen atom. Now, one problem is that this process from falling of ultraviolet ray over the water vapor and from that producing oxygen, this process is very slow. So, although this process is there, may be there, but to explain the concentration of present day oxygen apart from the ultraviolet ray radiation on the uh, water vapor molecules, it requires some other sources from where oxygen can emerge, and that source is found on the earth itself. That is, with time the earth gradually cools down, favorable climatic condition appeared, life appeared by some chemical reaction processes, and these life forms gradually emerge or gradually produce oxygen as a byproduct. So from that, the enriching of oxygen in the earth atmosphere gradually occurs. Now, apart from the major gases found in the present day atmosphere, in addition to that, the water droplets and the ice crystals in the form of fog, haze, or clouds are also found, along with some solid dust particles. Now, these dust particles have huge importance in the Earth's climatic condition, or in a small scale in the weather condition of an area. Because of the dust particles present in the atmosphere, the clouds formed, and these dust particles, they absorb part of the incoming solar radiation, and that radiation they reflect or scatter in different directions. And because of this reflection or scattering of incoming solar radiation, the Earth's sky looks different in color. It sometimes it appeared blue colored, and during the sunset or during the sunrise it appears reddish in color. So this variation in color, variation in color of the same sky, of the same atmospheric cover around the earth, is mainly occurring because of the selective scattering of the visible solar spectrum by the gas molecules as well as the dust particles found in the atmosphere. Now, if you look at the mass of the atmosphere, or there are some basic laws the atmospheric gases follows, and they change their uh, physical states due to some change in pressure and temperature, and these changes are following some very uh, fundamental laws. The first one is the Boyle's law, which states that at constant temperature, the volume of a mass of gas varies inversely with pressure. The second law is the Charles law, which states that at constant pressure, the volume varies directly with the absolute temperature. So if we club them together, we find that the three qualities of a gas, that is the pressure, temperature, and volume, they are completely interdependent. That means they are completely depending on one another. So with slight variation of one, it will cause to change the other physical properties. So with slight variation in pressure, that will cause to change in the temperature as well as in the volume of the gas. Now, if we look at the atmosphere of our Earth, the Earth atmosphere is basically a mixture of different gases. And these gases, they are occur around the earth because of the gravitational force of the earth. So it is the gravitational force of earth that bound or that holds the atmospheric gases, and due to that these atmospheric gases are not escaping to universe because of the centrifugal force. Now earth's atmosphere is consist of different layers, and this layering may be done, or we can distinguish different layers within the entire Earth's gaseous cover depending on the concentration of atmospheric gases. So there are various ways, various tools, various properties by which we can um, demarcate different layers within the entire Earth's atmospheric cover. The first property by which we can distinguish different layers is the concentration of atmospheric gases. Uh, if we look at the atmospheric uh, cover of the Earth, we found that from the Earth's surface, the atmospheric cover occurs up to about more or less 500 kilometer, 500 to slightly higher. Now, within this entire 500 kilometer above the Earth's surface, the concentration of atmospheric gases is not homogeneous. It is found that up to a height of about 80 to 100 kilometer above the Earth's surface, the gases the concentration of gases is more or less uniform. That means the chemical composition of atmosphere is more or less uniform up to a altitude or up to a height of around 80 to 100 kilometer. And this uniform chemical composition of atmospheric gases, that means up to the height of 80 to 100 kilometer, in all levels, the proportions of different atmospheric gases are more or less constant. So in 50 kilometer from the Earth's surface, what you get the proportion of atmospheric gases, almost in 70 kilometer from the Earth's surface, you will get the same proportion of atmospheric gases. Now this constant or uniform proportion of atmospheric gases up to the level of about 100 kilometer is mainly occurring due to turbulent mixing, and this layer of atmosphere is known as homosphere, as homo means equal. So as within this altitude the proportion of atmospheric gases is more or less uh, fixed, more or less uniform, so that portion of the atmosphere is known as homosphere. Rest of the part of the atmosphere, that is the portions above homosphere, and it extends up to a height of about 500 kilometer above the earth. In this portion, the proportion of atmospheric gases is not uniform. It varies a varies very uh, quickly. So this portion or this layer of the earth is known as heterosphere. So the entire 500 kilometer is now divided into two parts. One is the homosphere, that is the portions from Earth's surface up to a height of about 80 to 100 kilometer, and beyond this homosphere the proportion of gases varies, and that layer is known as heterosphere. Now if we look at the concentration of atmospheric gases within this entire 500 kilometer, it was found that within the homosphere, that is up to the level of 80 to 100 kilometer, almost or nearly 100% of the total mass of atmospheric gases present within this level. That means most of the atmospheric gases, they occur in the homosphere layer, and that results that the mass of air within the homosphere is nearly 100%. In the heterosphere, the concentration of atmospheric gases is very low. Now, apart from the concentration of atmospheric gases, the atmosphere can be again divided into several layers based on mainly from the surface with altitude, and this is known as vertical temperature gradient. Now, why the division of Earth's atmosphere into different layers is done on the basis of temperature? The other two properties of gases, that is the pressure and the density, the change of these two properties with altitude is occurring in a very uniform way. As you can see from the previous picture of the slides, where you can see the concentration of the atmospheric gases changes in a very uniform way from surface to the uh, upper part, from surface to higher altitudes. So change in density as well as change in uh, pressure of the atmospheric gases, they will decreasing with altitude in a more uniform fashion. So thereby demarcation of different layers on the basis of these two properties is very difficult or almost impossible. But in contrast, if we look at the change in temperature in the atmosphere from surface to higher altitudes, although the general consensus is that with altitude, temperature gradually decreases. That means as we move from the surface towards higher altitudes in the atmosphere, temperature gradually decreases. But throughout the 500 kilometer span of the Earth atmosphere, this change in temperature is not uniform. So there are certain regions when this general decrease in temperature in the atmosphere is not followed. So the general trend is not followed, as you can see in this picture also. So there, from the surface, gradually temperature decreases, and at certain level again temperature increase, then again decrease, again increase. So there are some sharp points or sharp levels in which the general trend disrupts, and because of this presence or occurrence of these sharp changes in the temperature profile of the uh, Earth's atmosphere, we can divide or we can distinguish the entire Earth atmosphere into certain layers. And depending on the change in vertical temperature, we can divide the entire atmosphere into 5 different layers. So the atmosphere is divided into 5 different layers because the atmosphere is not uniform, and its properties are also changed. The main cause of changing in properties or division of the Earth's atmosphere into different layers is the temperature. Now, as we came to know from the Charles and Boyle's law that uh, a minimum change or a slight change in temperature will cause also in change in the pressure, gas pressure, as well as the density of gases. So although the main cause is temperature, but along with temperature, the density and pressure of atmospheric gases in this entire 500 kilometer also changes. So let's look at each layer individually now. If we look at the layerings of the Earth atmosphere, the most or the fast atmospheric layer close to the Earth's surface is known as the troposphere. As tropo means mixing, so random mixing occurs, random mixing of atmospheric gases occurs within this region, and it spans about 16 to 18 kilometers from the Earth's surface. Above troposphere is known as the stratosphere, above stratosphere is mesosphere, above mesosphere is ionosphere, and above ionosphere the outermost layer of the atmosphere known as the exosphere. And in exosphere almost there is no gas molecules, only very low weight atmospheric gases like hydrogen or helium are found, and the concentration also is very low in the exosphere. So the first layer of atmosphere is known as the troposphere. We already aware of this name. It means that it is the region of the Earth atmosphere from the surface up to 16 or 18 kilometer, in which rapid mixing of atmospheric gases happened. So all the weather phenomena are found to occur within this layer. More than half of the air of the total atmosphere is occurring in this layer. So although within the homosphere, although within the 80 to 100 kilometer from the surface, uh, about 100% uh, atmospheric gases occurs, and among this homosphere, within the first 16 to 18 kilometer within the troposphere, about half of the air mass occurs. The temperature within troposphere drops with altitude. Temperature within troposphere drops with increasing in altitude. That means drops with height, and the general rate of decrease in temperature with height in the troposphere is about 6.5 degrees centigrade per kilometer. The troposphere is aimed at around 16 kilometer or 18 kilometer by a region, by a isothermal region which is known as tropopause, and above the tropopause the second layer of the atmosphere, that is the stratosphere, occurs, which extends from 16 kilometer to around 50 kilometer. The temperature in the stratosphere again starts increase, that means temperature goes up with altitude in the stratosphere. Most of the jets fly within this layer, as there was no atmospheric phenomenon, the weather phenomenon, that means the clouds, the cyclones are not occurring within the stratosphere. So this is basically a calm layer, and most of the aeroplanes, most of the jets, they are going higher, crossing the troposphere and fly in the stratosphere. In the upper part of the stratosphere, there is a concentration of ozone gas found, and this ozone gas acts as a protective cover, and it protects the earth from the harmful ultraviolet radiation of the sun. Ozone is basically a gas which is found in the upper part of the stratosphere. It protects the Earth from the harmful ultraviolet radiation. In the stratosphere or in the even in the troposphere, ozone act as a major pollutant, but in stratosphere, as we move up through the stratosphere, the concentration of ozone gas increasing, and around 40 to 50 kilometer altitude, ozone layer forms a distinct layer where the concentration of ozone gas is at its maximum, and this ozone layer absorbs the energy of the ultraviolet rays, and because of this absorption of ultraviolet rays occurs maximum in the top part of the stratosphere. So this is the cause due to which we find that the temperature in the stratosphere is increasing up through altitude. So in the entire stratosphere there are ozone gases, and the concentration of ozone gases increasing with altitude in the stratosphere. So as we move up through the stratosphere, we will get more and more ozone gases. These ozone gases absorbs the energy of the incoming ultraviolet radiation. So as the concentration of ozone gas increase up to the atmosphere, so the absorption of ultraviolet rays radiation energy is also increasing up to the atmosphere, and that will affect the temperature condition of the stratosphere. That will increase the temperature condition, the temperature of the stratosphere, and it will show a increasing trend, increasing temperature up through the stratosphere. The third layer of the atmosphere is known as mesosphere. The mesosphere separates out from the lower stratosphere by another isothermal region which is known as stratopause. Above the stratopause, the mesosphere occurs, and it extends from 50 kilometer to around 90 or 100 kilometer. In the mesosphere, again the general decline in temperature trend uh, is found to occur, and in this region the temperature drops often found to occur, and the temperature is often about minus 90 degrees centigrade to minus 100 degrees centigrade. So the temperature drop in this layer of the atmosphere is huge, and this is the coldest layer of the atmosphere. Most of the meteors they burn up in this layer. Radio waves are reflected back to Earth from the mesosphere. The fourth layer of the atmosphere is known as the thermosphere. Basically, it is a combination of two atmospheric gas layers. One is the ionosphere and the other is the exosphere. So together ionosphere and exosphere they known as thermosphere. So thermosphere ranges in altitude from 90 kilometer, that is above the mesosphere, to up to around 500 kilometer. It is the first layer to get exposed to the solar radiation. In the thermosphere, the temperature goes up with altitude as much as 200 Kelvin. It is the hottest layer of the atmosphere. As this is the first layer which get exposed to the solar radiation, so most of the uh, or maximum amount of the radiation energy, solar radiation energy, is taken, is absorbed in this layer. So this is more close to the solar radiation. So this layer is the hottest layer of the atmosphere. Now within thermosphere, as I already told you, the first layer is known as the ionosphere. This is the part of the thermosphere where the auroras are found to occur. Now, what are auroras? These are the curtains of light which are found to occur in the polar regions during night time. There are some excellent different colored lights uh, occur in the night sky of the polar regions. Now, why it is or how it is occurred, how these curtains of light, how these auroras formed. Now, when the incoming solar radiation falls on the first gaseous layer of the earth, the high energy of the incoming solar radiation, they will break the atmospheric gas and form some electrically charged ions. So any gas within these layers, within this thermosphere or within this ionosphere, they are broken down into some electrically charged ions due to the falling of incoming solar radiation. And these charged or ionized gases are moving very frequently from here and there within this ionosphere around 100 to 400 kilometer altitude from the earth's surface. So because of this movement of ionized charged ions within these layers, we can see these highly glittered curtains of light which are known as auroras. Now, due to the rotation of earth around its own axis, most of the charged ionized particles in the ionosphere, they are moving towards the poles. From the equatorial region, they are deflected or they are moving towards the poles where the rotational speed is low compared to the equatorial region. Because of this, although the electrically charged ions occur all through the ionosphere in all places, but because of the deflection of these charged ions towards the polar region, we can only see auroras in the polar regions. The last layer or the outermost layer of the atmosphere, that is known as the exosphere. The lower boundary of the exosphere is called the critical level of escape, where atmospheric pressure is very low, the gas atoms are widely spaced, and the temperature is very low. Most all the satellites, they orbit Earth in the exosphere. So if you look at the overall temperature profile of the atmosphere, you can see although there is a general trend of decreasing temperature um, through altitude, which is known as vertical temperature gradient, the observed rate of vertical decrease in temperature is known as the lapse rate. But this lapse rate is not constant. It varies with height, even with location or even with season. But the change in temperature with height is often found to occur very sharply, and depending on that, we will demarcate out some different layers within the atmosphere. So that's all. That's a brief introduction about the atmosphere and the different layers and its different properties of different layers, and how the atmosphere is differentiated or divided into different layers. So that's a brief introduction of atmosphere. Hope you will understand.